on the subtopics kinetic energy and momentum relationship. Then you have how to find out work done for a constant force or for a variable force. Then what is relation between work and energy? Then you have concept of potential energy. What is potential energy and how potential energy and conservative force are related. What is conservative force or what is non-conservative force, and what is the relation between conservative force and potential energy. Okay. Then one is kinetic energy and momentum relationship, work done concept, relation between work and energy. What is conservative and non-conservative forces, and relation between potential energy and conservative force. Then some of the conservative forces are, we'll study spring force and spring force potential energy relation, and gravitational force and gravitational force potential energy relation. Okay.
Yes, sir.
Then we'll study about types of equilibrium: neutral, stable, unstable equilibrium. And the other thing, and last but not the least, a very core important concept on which number of questions are framed, that is work energy theorem. Apart from it, you'll study about what is power, what is and problems on power. That's it. This is the basic concepts you'll study in this topic. Okay. Shall we go ahead?
Yes, sir.
Varun, are you ready?
Yes, sir. I am ready, sir.
Every time you come up with new posters for your photo. Till yesterday, you were with Mumbai Indians. Now they are qualified for playoffs. So suddenly your Clash of Titans, is it?
No, sir, it's PUBG.
It is PUBG. Now Mumbai Indians will play and win the matches. You might have got the confidence by now. Okay. Now, first thing is what? Kinetic energy. So for kinetic energy, it is the energy of a particle or a body by virtue of its motion. This definition you might have studied. Of its motion. Any moving body will have kinetic energy. So you might have known this formula of kinetic energy, half m into. You tell me, what is kinetic energy? Is it a scalar quantity or is it a vector quantity? Varun?
Scalar.
Huh?
Scalar quantity.
It is a scalar quantity. Energy is always a scalar quantity. Okay. So this can also be written as scalar product. How? Half m into v dot v. V dot v is what? V dot v is magnitude of v vector into magnitude of v vector into cos velocity vector, velocity vector. Both of them will have angle 0 between them or not?
Yes, sir.
That means v square or not?
Yes, sir.
So half m velocity vector dot velocity vector. Can we write like this or not?
Yes, sir.
Yes, sir.
There is other way of writing this. Half m into v dot v. I am multiplying with m and dividing with m. Okay.
Yes, sir.
If I rearrange this, mv dot mv divided by m. What is this? mv is nothing but what? Momentum vector.
Momentum, yes, sir.
Yes, sir.
P vector dot p vector by 2m, that is equal to
Yes.
p square by 2m. This is another relationship which is highly important. Number of
1 minute.
CBSE exams this relation is asked. CBSE final exams and NEET exams. Questions are asked on this relationship.
Sir.
You can solve a question on this.
Once scroll the screen, sir.
Okay.
Done, sir.
Okay. Now,
Hmm.
the question is, if for a given body,
Hmm.
for a given particle, momentum is increased by 100%, what is the increase of kinetic energy? How much percentage will be the increment of kinetic energy? You understood the question?
Yes, sir.
Yes, sir.
You solve this question. Try to solve this question. Okay. Kinetic energy is P square by 2m. Is the formula. Final kinetic energy is P final square by 2m. Initial kinetic energy is P initial square by 2m. So what is the increase in percentage means P final minus P initial by P initial into 100. This is whenever you get increments kind of things. This is the formula you need to use. Okay. If it is decreasing
Yes,
means
sir.
here you will get minus. If it is increasing means plus. So you increase it no, so plus 100. So answer will become how much? P final minus P initial is equal to P initial. That is P final is equal to 2P initial. Simply if you use this knowledge, P initial is 100% means entirely PI is added, increased. So the answer will become 2PI. 50% means
Yes, sir.
1.5 PI. Like that you can solve.
Yes, sir.
So now this has become how much? 2PI. So K final is 4PI square by 2M. That is nothing but 4 times of initial kinetic energy. So percentage change in kinetic energy means how much? Change in kinetic energy by original kinetic energy into 100. That is 4Ki minus Ki by Ki into 100. So that gives you 3 times of Ki by Ki into 100. That is 300% is an increment. Okay.
Yes, sir.
Yes, sir.
So another question I'll give you. If there is, if for a given particle, if for a given particle, there is a increase of kinetic energy by 50%. Oh, sorry. If there is a 64% increase of kinetic energy by 64%, what will be increase of momentum? Okay, momentum
Yes,
of the
sir.
particle. Varun, solve it.
Yes, sir.
Because this technique, whatever I taught you now, this kind of problem solving will be useful for you in number of physics and maths problems also.
Yes,
This,
sir.
this is increased by this much. How much is increment in that? Have you ever seen that kind of problems?
Yes, sir. I've used this more in modern physics, sir.
So there you will, there also you'll be able to. I thought of saying that modern physics number of questions will be there on this kind of method.
Yes, sir.
Now if you learn this in that topic, it will be awesome. It will become easy for you.
$64 only I got, sir.
How is it possible?
The same method I used.
Sorry, 64. You will not get the correct answer. Let me check. So you take this to be not 64. I'll change
Hmm.
it to you. 44%. 44%. Take to be 46. Varun,
Yes,
are you doing it? You carefully see this. So, so what is this? What is increment in momentum? So what is that? P final minus P initial by P initial into 100. We need to know this, is right?
Yes, sir.
So first thing, we have information in terms of kinetic energy. That is K final minus K initial by K initial into 100 is equal to how much? 44, isn't it?
Yes, sir.
So this is nothing but K final minus K initial by K initial. I can directly write also, but just I'm solving the procedure for you. 0.44, that is K final is equal to K initial plus 0.44 K initial. That is 1.44 K initial. You got it?
Yes, sir.
So we know that kinetic energy is equal to P square by 2m.
Yes, sir.
Initial kinetic energy is equal to P initial square by 2m. Final kinetic energy is equal to P final square by 2m, isn't it?
Yes, sir.
But we need to get P momentum in terms of kinetic energy. So I'll change this equation.
Yes.
P initial is equal to root over 2mk initial. This is a very important formula. This you will find in modern physics. Number of times this problem
Yes.
is there. P final is equal to root 2m k final. Varun, are you understanding this?
Yes, sir.
You understood this formula, basic.
Yes, sir.
Then what do I need? P final minus P initial by P initial into 100. So that is equal to root 2m k final minus root 2m k initial divided by root 2m k initial into 100. You got it?
Yes, sir.
So anyway, root 2m will be cancelled. So the answer is root k final minus root k initial by root k initial into 100. Okay?
Yes, sir.
Root k final means how much? 1.44 k initial or not?
Yes, sir.
K initial divided by root k initial. So root k initial cancel into 100. So one root over 1.44 means how much?
144 or 500. 1.2, sir.
1.2 minus 1 into 100. How much? 0.2 into 100. That is how much?
925 into 100. 36, sir.
What? 36. 1.2 minus 1 is 0.2. 0.2 into 100 is 20%.
Yes, sir.
The answer is 20%. This is simple. In general, in objective, how I'll solve? Now I understood the process. In objective, how I'll solve? I'll say momentum is the question asked. Kinetic energy is given relation. So I know P is equal to root 2m K immediately.
Yes, sir.
I need to find out only kinetic energy. Root 2m will remain constant anyway. How much
Yes,
is
sir.
increment happened in kinetic energy? 44%. That means how much it will happen? 1.44. You know this basic understanding, right?
Yes,
Yes.
sir.
At least after these problems, whatever is solved. So root of
Yes.
1.44 minus root 1 initial root 1 into 100. The answer is directly 20%. I got you. See, check it.
Yes, sir.
So when I become perfect in the basic understanding of this concept, so I will be able to apply in this way and solve in objective exams.
I understood, sir.
Varun, are you clear?
Yes, sir. I am clear.
So with me, concept will happen only along with problems. Then only you'll be able to understand physics and apply physics on your own.
Yes, sir.
This is a very important formula. So then, shall we go to next part? What is the next part? We understood the first part
Kinetic energy.
and momentum relation. So I'll just keep it out. Then what is the next part for us?
Work done.
Just in kinetic energy, they'll ask you graphs also. Kinetic energy versus speed. If graph is asked, how will you write? Kinetic energy versus speed graph.
Kinetic energy is directly proportional to speed, no, sir.
How? You tell me what is the formula of kinetic energy?
Half mv square.
Kinetic energy is equal to half mv square. Can I consider this to be constant?
Yes, sir.
So kinetic energy is equal to some constant into v square.
Yes,
Can I write
sir.
it as y is equal to kx square? So if you take x as graph, y as graph, kx square, how will you draw?
1 second, sir. Parabola.
Parabola. So similarly, kinetic energy, speed. When you're writing speed, you can only draw like this, okay? Why? Speed cannot be negative.
Negative, yes, sir.
If velocity is asked, same graph can be written as like this.
Okay.
Velocity can
Okay.
be negative.
Here V is velocity, not speed. Yes, sir, understood.
If speed is given, only one side of the graph.
Okay.
Varun, did you understand this?
But can we tell that kinetic energy is directly proportional to velocity, sir?
Directly proportional. It is proportional. Matlab, if velocity is increased, kinetic energy will increase. But
Okay.
how it is proportional? Power 2. X square.
Okay. Yes, sir. I got
Graph will be
sir.
like this. You can, by saying directly proportional, you are saying like this.
Yes, sir.
No, we cannot see. Okay, this graph is not. Got it?
Yes, sir.
Now the second part of our, what is it? How to calculate. Before understanding what is work and energy, we'll study about how to calculate work done. I'll tell you
Yes.
one important, given if information is given about force, displacement and everything, this work done calculation can be done in this
Easy.
following manner. One formula I'll give you. Varun,
Yes, sir.
are you careful?
Yes, sir.
Okay, carefully listen to this. One formula, work done. From that one formula, we can derive any kind of formula for work done. Is equal to integral f dot d
Yes.
r initial to r final. Here f is equal to fx I cap plus fy j cap plus fz k cap. R initial is equal to x initial I cap plus y initial j cap plus z initial k cap. R final is equal to x final I cap plus y final j cap plus z final k cap. Then dr vector is equal to dx I cap plus dy j cap plus dz k cap. If you remember this one, any kind of formula for work done can be derived.
Okay.
What did I take here? Integral f dot drs work done.
Yes, sir.
F is, that I'm assuming that F force is there in x direction, y direction, z direction. Displacement there is there in position of the particle. Initial position is x1i, y1i, j, z1k. That means xi comma yi comma ji point. It is there. Final
Yes,
position
sir.
is x final minus x final comma y final comma z final. Dx is the small displacement along the displacement vector. You got it? Along x, y, z. Now, you might, if you have in exam, only one direction force is there, x is there. Fy will become 0, fz will become 0. Only fy is there. Fx will become 0, fz will become 0. Only x direction displacement is there. So y initial, y final 0, z initial, z final 0. So are you understanding?
Yes, sir.
We will do according to the situation, how displacement is there. Now,
Okay.
you know your mathematics concept. If special case, where you might have solved number of times by using this formula. Special case is if force is constant. What?
Force is constant.
Force is not varying. Given force is a fixed force.
Hmm.
You know this integral f dot dr. How can we write this one? F can be taken outside or not?
Yes,
Mathematically.
sir.
Varun,
Yes, sir.
Varun,
Yes, sir.
mathematics, you know this. For if suppose integral a dot something, sorry, integral some a dr. If a is constant, can we remove a outside of the bracket?
Yes, sir.
Like this, can I write it as integral f dot dr?
Yes, sir.
R
Yes,
initial,
sir.
R final. So if I integrate dr, what will you get? F dot
Uh,
R you will
R and
R initial to.
R final.
So that is equal to, can we write it as F dot delta R or not?
Yes, sir.
This
Sir.
you might have by hearted it as force dot
Fs.
displacement. Otherwise, Fs cos theta.
Yes, sir. I by hearted it, sir.
So if you know this formula, any kind of force, if it is variable, we'll, if x, y, z, all the direction force is there, we'll use this formula. If only one direction it is there, y, z will become 0. If only one direction displacement is there, remaining will become 0. So if only it is constant, this formula will come.
Okay.
If 0 less than theta less than or equal to 90,
Hmm.
0 less than or equal to theta less than or equal to 90, work done will become positive. Theta is equal to 90, work done will become negative. Sorry, 0.
Hmm.
Fs cos 0, cos 90, 0. If theta greater than 90, that is work done will be negative. You got it? In case force is constant, these cases will be formed.
Only from 90 to 270 it will become negative, sir.
90
300.
to 180.
Hmm. Yes, sir.
There will not be possibility of 270. Why?
Okay. Only up to this level. You can't go negative way.
No, you see, if force is like this, just I'm telling, two vectors are there. Two vectors cannot have angle more than 180. Why? Because suppose this is 120, you see, okay? If I am trying to rotate this for another 60 degrees, for suppose, assuming,
Hmm.
you might say not 60, 100 degrees. So you might say this is 220 degrees, right?
Yes, sir.
At that time, angle will become this one.
Yes, sir. I understood.
Angle will become 360 minus 220, that is 140.
I remember, sir, now.
Varun, are you getting these things?
Yes, yes, sir.
The two vectors angle can be only from 0 to 180. Theta greater than 180, greater than 90, 180 greater than theta greater than 90, it is work done is negative. Okay, are you getting this?
Yes, sir.
Next, shall we go to explain? I have given you information about how to find out work done if force and displacement are given.
Yes, sir.
Yes, sir.
One is complex thing. Complex means force is also variable, displacement. Then we have to integrate. If force is constant, directly F dot S we can do.
Yes, sir.
And positive, negative, or 0, it will depend upon the angle between that force and displacement. Okay.
Yes, sir.
Yes, sir.
Now, this concept explanation of work done is over. Now, the next part is how work and energy are related. How?
Work and energy are related.
So work is actually a form of transferring energy. So if you do work, suppose there's a person, there's system 1, okay? There's another system 2,
Yes, sir.
system A or system B. Now, if this person takes 5 joules of energy from this system and has given this to system B, okay?
Hmm.
This person has done negative work on system A, that is 5 joules of energy he took, that is nothing but negative work done. He did negative work on system A and did positive work on system B. Positive work, how much he did? 5 joules. He took
Hmm.
5 joules of energy from A and given 5 joules of energy to B. This act
Okay.
of taking energy is called work done. This act of giving energy is also called as work done. If you remove energy from the system, then it is negative work done. If you provide energy to the system, that is positive
Work done.
work done.
Yes, sir.
Suppose if you are throwing a ball, so you are giving some energy to the ball, right?
Yes, sir.
So you have done some work on the ball.
Hmm.
How that work is done? The ATP molecules which are in your body, so they lost the energy. That means from the ATP molecules, your hand has taken energy, your muscles have taken energy from that system and has given the energy to the ball. So
Hmm.
they have done negative work on that ATP molecules, muscles and everything, and they have done positive work on the ball.
Yes, sir.
Yes,
So
sir.
this energy generally we generally not discuss. So whenever you take energy from system, that is you are doing negative work on the system. Whenever you are giving energy to the system, you are doing positive work on the system.
Hmm.
Yes, sir.
Varun, you got it?
Yes, sir.
I don't think you might have understood this kind of simple definition for work and energy, isn't it? You might have studied this topic.
Yes, sir.
So you simply see this. Suppose a ball is there. I'll show you another example here. A ball is falling down means gravity is downwards.
Hmm.
Displacement is also downwards.
Hmm.
So work done by gravity is how much? Positive or not?
Yes, sir.
So
Yes,
you
sir.
see, ball's kinetic energy keeps on increasing. You see,
Okay.
gravity is giving energy to this ball. You see, it is doing positive work.
Yeah.
That means it is giving energy to the ball.
Yes, sir.
Yes, sir.
Suppose a ball is thrown upside with velocity u. So slowly, what will happen? Displacement is upwards, gravity is downwards. So work done is how much? Negative or not?
Yes, sir.
Angle is 180 degrees. Cos 180 minus 1.
-1.
0 is 1 here, plus 1 here. So now what is happening? Negative work is being done on the ball. Slowly the ball's kinetic energy will decrease or not while going upwards. You see?
Yes, sir. Understood.
So gravity is giving energy here to the system, is taking energy from the system.
Yes, sir.
Yes, sir.
You understood what is work and energy relation?
Hmm.
Yes, sir.
So you can write a definition here. Positive work means what? Giving energy to the
System.
when work done by force is responsible for decrease in energy, then it is known as negative energy. So positive work done means what? When a work done by force is responsible for
Hmm.
increase in energy, then it is known as positive work done. Positive work done. Theta less than 90 degrees, generally it happens. If negative work done means what? work done by a force is responsible for decrease in energy, then it is known as negative work done. And here in that case, theta greater than 90 degrees. Okay.
Yes, sir.
Yes, sir.
Last thing, if suppose one dimensional displacement is there, suppose one dimensional force is there, so I can write it as integral f dot dr as integral fx dx.
Yes, sir.
Okay,
Hmm.
because fy dy fz dz will become 0, isn't it?
Yes, sir.
So I already taught you this very important concept in the previous one of our previous class. Whenever this kind of things come, integration of x initial to x final, what is that graph? I told you. You remember
Straight.
fx
Yes, sir.
graph, area under the curve,
Yes, sir. Yes, sir. Yes,
forward,
sir.
x final. So
I
we'll give
remember.
you work done, left side term that is here, work done here.
Yes, sir.
This is another important conclusion, 5-star. I already taught you in the previous class, integral fx dx.
F into x initial minus x final.
So here, area under the curve, f and x
Hmm.
will give you work done.
Yes, sir.
Got it?
Yes, sir.
So now, here generally work done depends upon what? Force, displacement and angle between them, okay?
Yes, sir.
Now, will you solve some problems?
Yes, sir.
We'll do it in the next class, okay?
Okay.
These 3 parts. You revise these concepts. Let me solve 2 problems in this. Suppose a force is there, like this 100 newtons. There's a block is there, 5 kg block is there. So now, this is kept on the ground. What is the work done by this force? So, by all the forces possible here. If this block is displaced by some 20 meters, okay, along this ground, work done by all the forces here, all the forces possible. I gave you a force 100 newtons. Okay, Varun,
Hmm.
can you try? Will you try this? Try solving this question.
Sir, is it rough surface or smooth surface, sir?
It is smooth here. Okay,
Okay. That means no friction.
no friction.
Cool.
Varun,
Yes, sir.
solve this question.
Yes, sir.
I'll explain you.
200, sir.
200 of what?
Work done.
Take your time and solve the question.
Okay.
So let me solve this question, okay?
Yes, sir.
So you see here, there are three forces here. One is mg, other is normal reaction, okay,
Hmm.
and this 100 newtons force. Varun,
Hmm.
Varun.
Yes, sir.
So now you see here three forces. I'll write it as work done by gravity here. First question, okay. How is gravity acting like this?
Yes, sir.
Is displacement acting like
Down
this? Angle between them is how much?
90.
So the answer will be 5g into displacement is 200 into cos 90 is
0.
0, 0. The answer will become
0.
so next work done by normal force is normal is equal to 5g here.
Yes, sir.
50 into 200 into cos 90 again. Okay or not?
Hmm.
Again cos 90 is 0. That is answer is 0. Okay.
Hmm.
Yes, sir.
Here I did not give you the angle, right?
Yes, sir.
This angle you take it to be some 60 degrees. Okay.
Okay.
So now work done by external force, that is whatever the force I gave, is equal to 100 into displacement into cos of angle between them, that is cos 60.
Cos 60.
Cos 60 is how much? Root 3 by 2. So 200 times.
And
What is the answer? 100 into 100 into root 3. Root 3 is 1.732 into 10 power.
Cos
That
100,
is
sir.
1. That's it. 1.732 into 10 power 4 newtons is the work. Sorry, joules is the work done.
Hmm.
Got it? You understood how I'm finding out the work?
Yes, sir. I understood.
Another way, another question. So force is given as 5x I cap if x initial is equal to 1 meters and x final is equal to 2 meters. Tell me what is the work done? Varun, solve it. Shall I explain it? Varun,
Yes, sir.
are you doing it or should I explain?
Once you only explain, sir.
You see here. Is the force constant here? Tell me. There I gave 100 newtons directly. You wrote it as force into displacement. Is the force constant here?
No, sir.
Varun,
no, sir.
force is variable or not?
Yes,
Yes, sir.
If force is variable, what is the main formula? Force is
Integrate.
F dot dr, but here only one direction is there. Fx is there. Only x direction is there. So can I write it as fx dx?
Yes, yes, sir.
If two directions is there, I will write it as x initial to x final fx dx plus x
Yes,
final
sir.
y initial to y final fy dy
Yes,
plus
yes,
z
sir.
initial to z final fz dz. But in this solution, fy is not also 0, fz is also 0. So then directly answer will be integral fx dx
D.
x initial to x final. Work done. What is this?
Yes, sir.
Fx is 5x dx So x initial to x final. That is 5x square by 2. From where to where? 1 meter to 2 meters. So 5 by 2 into 4 minus 1, that is 3. To 15 by 2, that is 7.5 joules is the correct answer. You got it?
Yes, sir.
Other problem, another problem, another question. So, given force is equal to 3x I cap plus 4y square j cap. Displacement is from 1 comma 2 to 3 comma 4. Okay. What is the work done? Are you getting?
Yes, sir.
I hope you will be able to solve this problem.
Yes, sir.
Varun, are you trying this question? Arey, is this class more smooth as far as internet connection is concerned?
Sir, I'm not able to listen, sir.
Is this class more smoother than the previous classes? In terms of,
Yes, sir.
huh?
Yes, sir. I'm not able to see you, sir.
You are not able to see me. Is this class till from when you are unable to see me?
Just like when you asked this question first time, sir.
Is this class more smoother with respect to internet connection and all?
Yes, sir. It is.
Is it or not? Or is it
It
like,
is, sir.
or it is like similar to previous classes?
It is similar to previous classes, sir.
I have changed my internet connection. Just I have increased it. I don't know whether it is actually.
Okay.
You do not see any difference from the previous class to this class.
Yeah, no, sir.
Okay. Varun? You see here. Here there is two directional work. X direction and also there. I cap and y direction j cap is also there. So integral fx dx, x initial to x final, plus integral
So something 54, sir.
dy, y initial to y final. Fx is how
Yes,
much?
sir.
3x
One
dx
DX. Yes, sir.
from here 1 to 3 plus 4y square integral from 2 to 4
2 to 4.
dy. So the answer will be 3x square by 2 from 1 to 3 plus 4y cube by 3 from, this is basic mathematics only, okay? You mathematics
Done, sir.
not face any difficulty in this. So 3 by 2 into 9 minus 1 plus 4 by 3 into 64 minus 8. The answer is 3 by 2 into 8 plus 4 by 3 into 64 minus 8 is how much? 56. The answer is how much? 6 if you take LCM. You can solve this question finally. 3 3 is 9, 9
Yes,
8.
sir.
Yes, sir.
You can solve 9 8 are how much? 72 plus 4 into 56 into 2. So you can solve this answer and get the answer. You got it? How
Yes.
you solve this question?
Yeah, same, similar.
Joules. So
Hmm.
3 dimension is there.
54.
Integral fx dx plus integral fy dy plus integral fz dz can be solved. Okay.
Yes, sir.
I'll give you another third question like similar model. F vector is equal to xi cap plus yj cap plus zk cap from 0 comma 0 comma 0 to 1 comma 2 comma 3. Okay. You can solve it as a homework. Okay. What is the work done by this force? If this force displaces the particle from 0 comma 0 comma 0 to 1 comma 2 comma 3. Okay.
Yes, sir.
Final question is, final model is,
Hmm.
there's a graph, F is there, displacement is there. This is x is equal to 2. This is x is equal to 4. This is 10 newtons force. So what is the work done by this force from x is equal to 2 to x is equal to 4 in displacing from x is equal to 2 to x is equal to 4? You got it?
Yes, sir.
What is the work done? Varun, are you able to catch?
Yes, sir.
First thing I did with the constant force. Second thing
Constant.
I did with one-dimensional force. Third thing I did with the two-dimensional force. Fourth question I did with three-dimensional forces and variable forces. All the three questions. And then I'm doing the graph question.
Yes, sir.
Yes, sir.
If you have understood how to do, you can solve how to find out work done in different kinds of questions in previous years or in HC Param also. Or any material you take, you can easily solve it.
Twenty, sir.
Let me force is here. You see this area under the curve from where to where? X is equal to 2 to
4.
4. Area under the here how much? This is a rectangle, right?
Yes, sir.
Yes, sir.
That is rectangle is turned into breadth is how much? 2. 4 minus 2.
2.
That is equal to how much?
20.
20 joules.
20.
Hmm. Gotcha.
Yes, sir.
If from 0 to 4 the question is asked, this triangle also will come into picture.
Yes, sir.
So
Plus
this
half into base into
half into base into 10 height.
base.
So 10 joules.
Hmm.
If 0 to 4 the question is asked is 30 joules. If only 2 to 4 the
Yes, sir.
question is asked is only 20 joules. If 0 to 2 that is 10 joules. You got it?
Yes, sir.
Yes, sir.
This is the way you solve the problems. From HC Verma and your materials, you can find how to find out work done. You can use whatever I taught you and solve any kind of problem in this questions.
Okay, sir.
Okay, sir.
Okay, just for finding out the work done. So in the main heading, the main things are what? Work done is solved for by constant variable thing is solved. Work and energy relation is cleared, isn't it? And we have done problem with this 3 part. Next class we'll study about conservative, non-conservative, and potential energy concepts.
Hmm.
Just the 3 parts will be completed next class, and third class these 2 parts, and your syllabus, this topic will be over in 3 days. 1 day is completed here. In another 2 days, this topic will be completed.
Okay, sir.
Okay. Thank you. I hope you might have understood this concept clearly.
Can I solve HC Verma problem, sir?
You can solve.